Hello, here in this video we will be showing you how to solve trig proof and how to graph sine and cosine, and also how to solve trig equations. First we will be showing you how to solve for trig proof problems. So in this problem we can see that there's secant theta plus tangent theta equals cosine theta over 1 minus sine theta. To be able to solve for these problems, first you have to see how to approach and to try and figure out the answer, how to prove that it is the answer. So as we can see, the final answer that we have to prove is in cosine and sine, meaning that we have to change secant and tangent into cosine and sine. So as we all know, secant is 1 over cosine theta, whilst tangent can also be seen as sine theta over cosine theta. And since now they are fractions and they're added together, it means that you have to multiply the denominators and then later on the crossing. But since these two fractions have the same denominator, it'll just stay the same as cosine theta over 1 plus sine theta, since they're added together. So now you see, oh, I finished. But no, actually the final answer has 1 minus sine theta at the bottom in the denominator, meaning to be able to have that later on, you have to multiply the denominator by 1 minus sine theta, and what you do to the denominator, you have to do to the numerator. So when you multiply them, you can actually see that both of these, the numerators are the same, but the only difference are the signs, meaning that it'll finalize the final answer for that one. When factoring it, will be a squared minus b squared. So when factoring them, it will actually be 1 minus sine squared theta over cosine theta times 1 minus sine theta. But the thing is, now you figure out that this is actually equals to cosine squared theta, making it easier for us to cross cosine. So the numerator is actually cosine squared over cosine theta 1 minus sine theta, meaning that you can cross one cosine from here and the whole cosine from there, leaving you only with one cosine in the numerator and 1 minus sine theta, proving that it is the final answer for this problem, the trig.
Solving a trig proof problem, you have to show the steps to getting the answer that is shown. For tangent squared x times sine squared x equals tangent squared x minus sine squared x, we first have to convert sine squared x to 1 minus cosine squared x. For the next step, we multiply tangent squared x by 1 and tangent squared x by cosine squared x. So we are left off with tangent squared x minus tangent squared x. Tangent squared x times cosine squared x. So now we convert tangent squared x into sine squared x over cosine squared x, meaning we cross out cosine squared x. And now we get the answer tangent squared x minus sine squared x.
Now following along to solve a trig equation, we have this example that has the square root of 2 cosine theta plus 1 equals 0. And the main point of this trig equation is to be able to find the angle or the radians of this equation. And this trig equation can be solved just to how you will solve an algebra equation, where to be able to get the angle, the cosine theta alone, will be able to subtract 1 first, and then later on divide the square root of 2, and then later on you will have negative 1 divided by square root of 2 equals cosine theta. But to be able to find the angle or the radians, you have to do the inverse of any variable. For us, it will be cosine. So cosine inverse equals negative 1 square root of 2. But the thing is, if you see to the unit circle, there's no negative 1 over square root of 2. So how do we find the angle? Well, to solve that, you have to multiply this times the square root of 2 square root of 2. So why you have to multiply by that will be mostly because you see here the denominator is square root of 2, so it will be more logical to multiply by that. And when you multiply by the denominator, you have to multiply to the numerator. So when you multiply these, you'll get negative 1 square root of 2 over square root of 2. And that is actually negative square root of 2 over square root of 2. So this is what we have to find in the unit circle. So when you go to the unit circle and search for this, you will see that it is only found in 5 pi over 4 and 3 pi over 3. So when I go to a unit circle, the only negative 2 squared that is in the cosine side will be here in negative 4 and 5 pi negative divided by 4 and 3 pi divided by 4. This is the cosine side, and this is the cosine side. So right here, when you think it is this one, it is not, because this is the sine side. Mostly because of this, where it says cosine theta and sine theta. So the cosine is always in the x side. Just as here is an x, and also here is also an x.
For this problem, we will isolate cosecant theta first, and that means we will have to subtract 3 from both sides. So we have 3 cosecant theta equals 3, negative 3. So now we divide by 3 from both sides, which leaves us with cosecant theta equals negative 3 over 3, which is negative 1. Since it is not sine theta, then we have to turn cosecant theta into sine theta, and we know that cosecant theta is 1 over sine theta equals negative 1. So now we have to find the radiant of this equation. So we look at the inverse sine theta of sine theta. which is -1. And if you plug this into the calculator, it will give you 3 pi over 2. But if you look at the unit circle, and you look for -1 in the y-axis, it also gives you the 3 pi over 2, which is 270 degrees.
So when graphing sine, you have to take into consideration the equation of y equals a sine parenthesis bx minus c plus d, or this one, showing you different ways of how the equation can be seen. So a means amplitude, mostly to how it will limit the range of the waves, the sine waves, and b mostly to find the period and like the period of cycles it will take. So there will be period 2 pi or period pi. So here to be able to find the period, you have to use the formula 2 pi over b always, and the c will be used to find the phase, mostly also referred as the horizontal shift, and the formula for it will be c over b. And later on d, which is the vertical shift, and showing how it will be a vertical shift, either up or down, mostly based on the sine. So our equation to try and graph a sine will be this equation, which is y equals 1 minus sine parenthesis 3x equals pi over 3. So first you have to verify the amplitude, the vertical shift, period range, and phase shift. So now we have to find the amplitude. So the amplitude is always in front of sine here in this area, and as we can see, it has a negative in front of sine, only meaning that there's probably a invisible number 1 there. So the amplitude will be -1. But the thing is, even if the amplitude is -1, it will end up being only 1 when in the graph, when it limits the range. And to find the vertical shift will only be as either the front or in the back of the equation. So here it has the vertical shift in the front, and it doesn't have a negative sign, it has a positive sign, meaning that the vertical shift will be positive and will go up. So it will be positive vertical shift, shifting it up. And now for the period, we have to take into consideration the formula to find the period, which is 2 pi over b. So b here in this equation is 3, so it will be 2 pi over 3, which determines the cycle of the sine waves. And now to find the phase shift, which also has a formula, which is c over b. So we already know the b, that is 3, and the c here will be pi over 3. Even though pi over 3 has a negative in front of it, it will change it. So instead of being negative, it will actually be a positive. So it is pi over 3. So pi over 3. But since it's pi over 3 over 3, that's not possible. So you have to put 3 over 1 and do the AB thing, where first the AB thing where you multiply these and multiply those. So the real phase shift will be pi over 9. And now to graph it will be, so here's the actual graph of the sine of the equation, where now the new origin will be in pi over 9. So pi over 9 is right here, pi over 9, less than pi over 4, meaning that this is the new origin. And also stating that the vertical shift from 0, which is right here, will now be 1. So the vertical will be 1. So this is the new midline now of the graph. And also how the amplitude is also 1, saying that this is 2. So the maximum of the sine graph is 2, and the minimum will be -1 here. And to be able to graph a sine graph, you have to keep in mind that first you have to start from middle, low, middle, high, middle, low, middle, high, middle, low. And also do the opposite to the other side of the graph, which will be middle, high, middle, low. So this is how you will graph. First, you'll put the first point here in pi over 9 as the middle, and then later on, since you have to have sections, since pi over 9 is this section, this section, this section, this section, as a cycle. So this is a whole cycle right here. So this is only one cycle, this. So you will graph, you will point middle, low, middle, high, low in the pi. So here's the first pi over 9, and then later on the other pi over 9.
For graphing cosine equations, you need to know that our wave line will look different from a sine equation. Usually for sine equations, the line starts from the midline to the highest point to the midline, to the lowest point to the midline, which is and their highest point and their lowest point is also known as their amplitude. So our line should look like, start high, middle, low, middle, high. Our amplitude will be the number that is in front of cosine, which is 4. The period will tell us, and then the period will tell us where the cycle ends in the wave line. And you get the period by using 2 pi over b. B is the number in front of x, which is 1, so it is 2 pi over 1, which is equals to 2 pi. Our phase shift is will be the where the cycle starts. So we get it by using c over b, and c is pi over 2. And make sure you use the opposite sign in the equation. So it will be pi over 2 over 1, which is pi over 2. For the vertical shift will tell us where our new midline is going to be. So the vertical shift will always be the last number. Sometimes it will be in the front of the equation, but for this problem it is 1. And I'll do the domain and range after graphing the equation. Since our vertical shift is our new midline, which is 1, we will draw the midline. And since our phase shift will be pi 2, you can also draw the phase shift. now that we know what our phase shift and vertical shift is, we can start by putting in our amplitude, which is 4. So we start with 4. So it's 1, 2, 3, 4. And then we go to the middle. As you can see, the phase shift affected where the cycle ended. So our cycle did not end in 2 pi, it will end in further. Now we can complete it from the other side. So we can go back to the middle and then to our lowest point, back to the middle, to the highest point, and then to the middle. And now we can draw in our line. Now we can get the domain, and as you can see there's no ends, so our domain is negative infinity, infinity, and our range will be 5 and negative 3. So start with the lowest number, 3.